Good morning, dear students. How are you all? Fine. So this is a video of class 9, and in this video we are going to discuss about the topic, and that one would be the measurement of atomic mass and molecular mass. So we know that atoms are very small. Okay, if I will talk about the atoms, then you can imagine if one stadium I am considered as atoms, its nucleus would be very small. If one of the element is that much big, its atom would be very small. Okay, now so we cannot see that easily. Even with a powerful microscope, we cannot see. So its atomic mass measurement uh, would be one of the tasks which is very tough. Okay, now so you can see that here, the imagine that how difficult it is to measure the mass of atom individually. It is very tough. So this is actually solved by relative atomic mass. Earlier in the physics you have done about the density. Relative density means sometimes we are actually imagine some of the density in respect of other thing, relative density. So we are actually talking about the relative atomic mass, means in reference of some of the elements we are actually considering about that one, about a new elements atomic mass. Okay, now so here some of the reference material would be there, and earlier the very first one was the hydrogen. Again, relative atomic mass, you should know here it is relative atomic mass, and relative atomic mass means reference material should be there. So here you can see the relative atomic mass definition is there. When the mass of the element is compared, every time there should be the comparison. If I have taken the basis of the that reference material is hydrogen, then I will compare every time, I will compare each and every element's atomic mass in the reference to hydrogen. Okay, now I will compare if hydrogen atomic mass is this much, then why it is increasing, why it is decreasing. Okay, now so relative atomic mass is, you can see the standard reference elements, we will consider that one. So earlier it was hydrogen. Here you can see when the mass of the element is compared with some standard reference material. Okay, na? A standard reference element, and that one would be hydrogen, that can be oxygen, that can be carbon. So we will understand each and everything. Then the atomic mass is called relative atomic mass. Okay, now so relative atomic mass, every time we are talking about the two things. First of all, a new element's atomic mass, and second thing, the earlier reference material. So that one is the relative atomic mass. Here you can see hydrogen as a reference. Earlier it had actually taken as the hydrogen as a reference material, but the problem was there with the isotopic forms of the hydrogen. You know all, dear student, that if I will write here, then hydrogen, if I am talking about the hydrogen exists in three isotopic form: 1 hydrogen, 2 hydrogen, 3. Its atomic mass actually varies. So you can see this atomic mass 1, 2, 3. And if I will find out the average, this one would be the different one. This one is having some problem. Here you can see hydrogen as a reference material, it is the lightest gas also, and mass of hydrogen was taken as 1 unit. Okay, now and if we will calculate its average, the masses of other elements were compared with hydrogen, and it is dissimilar, not the similar one. So we cannot actually say that hydrogen taking a reference material was the correct one. And we can say that how can you calculate the RAM means relative atomic mass. You can say that relative atomic mass is this one, mass of one atom of given element upon mass of one atom of hydrogen. So you can see here the reference material I have written here. Every time reference material I will write. Okay, now so you can see there mass of one atom of the given element is actually in the numerator case, and every time it is in the reference material would be in the denominator case. Okay, now so second one, you can see hydrogen as a reference material. Here the problem is written, what I have told you, that it was actually proved inconvenient as hydrogen has 3 isotopes, 1, 2, 3. The average mass is slightly higher than 1. Then after we have discarded hydrogen as a reference material, then we have taken the oxygen as a reference material. But same thing was there. It has again discarded because isotopic form of oxygen was also there, and the measurement of atomic mass was having some problem. So that again we have actually discarded. Now we are actually working with the carbon 12 as a reference material. You know, their carbon is actually exist in the isotopic form. Carbon 14 also is there, carbon 12 is also there. So finally we are actually taking the carbon 12, and IUPAC has also approved that carbon 12 is the best one for calculating the relative atomic mass. Okay, now you know that carbon 12 is a stable isotope of carbon. Carbon 12 is a stable isotope of carbon which does not change with time. Means if the time will pass, then carbon 12 will not decay in the quantity and it will not decompose any more. So it is a stable isotope, and it was suggested that 1/12th part of mass of carbon 12 be taken as 1 unit of mass on the atomic scale. Okay, na? Oh, sorry. Here E should be there, but it is impossible to write here SCALE. Okay, now so this is known as the atomic mass unit. You can see carbon 12 is a stable isotope of carbon which does not change with time. Okay, now, and 1/12th part of mass of C12 atom you have to take. Okay, now, so RAM if I am writing, so 1/12th part of C12 atom. So yes, it's 1/12th part would be there. Then after atomic mass unit you can say, then atomic mass unit, what is atomic mass unit? Atomic mass unit can be defined as exactly 1/12th. Yes, I have told now in the previous formula I have given. Here it is also written 1 AMU, where it is 1 AMU is equal to here 1/12th the mass of C12 atom. It is every time atomic mass unit. If you are going to define, then atomic mass unit can be defined as exactly 1/12th, exactly 1/12th the mass of an atom of carbon 12. Okay, isotope on the atomic scale. So I will compare everything with this formula. Nowadays the atomic mass of the atom is compared with this 1/12th part of the mass of carbon 12. So if there is one of the example, if I will take relative atomic mass of sulfur atom, so is 32 AMU. What does it means? It means that the sulfur is 32 times heavier than 1/12th part of carbon 12 atom. So that means you can see, if any of the atom is there and its atomic mass we know, then we will simply go and calculate. We can go and compare with that one. I have written sulfur, atomic mass is 32 AMU. If I have written carbon 12 we have actually taken, oxygen 16, okay, na? Nitrogen 14. Okay, so if I am talking about what it is the meaning of 32 AMU, as you know, AMU is equal to 1 AMU is equal to same thing 1/12th part of C12. Okay, now C12. So 32 AMU, what does it mean? This AMU you can, this 1 AMU you can write in place of this one. AMU can be substituted with 1/12th part of C12 atom. So what does it mean? It means 32, as sulfur is 32 times heavier than 1/12th part of carbon 12 atom. So this is something you should understand, that if I have written 32 AMU, if I have written 14 AMU, if I have written 16 AMU, if I have written any of the measurement, any of the AMU, that is heavier than this AMU. 1 AMU, 1 AMU is equal to 1/12th C12 part of this carbon atom. So every time you should understand that carbon, nitrogen, oxygen, fluorine, whatever there would be there, that is heavier than C12 atom, 1 by 12th part of C12 atom. Okay now, so this one is the atomic mass unit. Okay, now then after you can see the fractional atomic mass. What is the fractional atomic mass? Some elements have fractional atomic mass, means fractional means na, fractional decimals. Okay now, 1 by 2.5. so some atoms have fractional atomic mass. And why this is so? Because this is actually existing in the isotopic form. Suppose chlorine is there, so its isotopic form is 35 also, 37 also. And if you have the known quantity of the ratio, what is chlorine 35 is existing in the atmosphere, what is Cl 37 is existing in the universe, so we can calculate this by calculating fractional atomic mass, and every time it will come in the fractions. So this is the method given here, and you can see it is written some elements have fractional atomic masses because these elements have different isotopes, and the calculation method is there. Then you have to actually multiply its ratio with the isotopic form, so 3 into 35 plus 1 into 37, and upon numerator that ratio you have to add, and it will come 35.5. here at the bottom it is written. Okay dear students, so this is fractional atomic mass. I hope all of you will do that one. Thank you.